And Daniel Du was with Christian Smedberg at the desk, talking a little bit about what we have for options for manufacturing, and we're going to show you a little bit about what he was talking about earlier. Before we do that, we'll let you know that we are going on Facebook right now. YouTube will probably be later, so that's the way we can work around our technical difficulties. So, without further ado, I'm going to bring Daniel Du in here. Come on, Daniel. Daniel, why don't you tell us a little bit? I saw your presentation earlier. Fantastic. We heard a little bit about your concept of manufacturing. And now we get to show everybody what you were talking about.
Yeah, effectively what we're going to show here is what we call the rip cut line. Right? This isn't pressurized, it's really hot in here, right? In case you wonder why we're sweating. This is take two because
that's why we do most of these in Mooresville in the air conditioning.
Yeah, so effectively what we're going to show is how to go from order entry to a bunch of cut parts, wood components, right, in the fastest amount of time possible. Right, so what we have behind us is a series of machines, right, and I'll just sort of go through them with you. We have a rip optimizer, right? So we're just going to drop the boards on the deck. It's going to get the width and the length. It's going to do an optimization. It's going to pass through a moving blade rip saw. So it's basically going to take that and identify the fixed widths and the randoms. It's going to come through the sweep deck and go lateral chain deck and go over to the marker at the diameter optimizing saw. He's going to pick it up in that gap right there. When we get to running, it'll be more clear. He's just going to take a crayon and identify what's a cabin door, what's not a cabin door. He's going to put it on an LCF, lateral chain feeder. It's going to go up to the dimter. It has width measuring, so now the dimter will be able to isolate the fixed widths from the random and do a length optimization. Cut the parts into dimension onto the sort line where we have an inkjet printer where we're going to identify the destination of every part, and then we're going to cart slot the parts immediately upon the sort line. So we're going to make a custom order, we're going to run it through Envision, it's going to make all of the cut lists, all of the rip lists, right, and we're just going to implement it on the rip saw. Right, when you import in the rip saw understands what the components are for every rip item, and it's going to forward those parts onto the dimpter. Right, so we'll take variables like yield. If you think about wood processing, one of the biggest variables is species per yield, because you might not get the same yield when you run mahogany as maple. So we take the history of the chop saw into consideration, factor it in the rip saw, so that when we import it, we have all the overages factored into the rip saw. So with that, I'm going to pass it over to Nathan Gower. Nathan's going to make us an order through Envision, and he's going to implement it on the system. And then we'll try again to run this and see how we do.
Let's do it again.
All right.
All right, follow me. Let's make an order with some doors in it. All right, so this is that screen that you might have heard of earlier that Christian talked about, right? This is InVision, this is our visual browser. Here's some of the unique products that we've manufactured with it. Right, so let's get right into it. Let's grab some cabinet doors. We're gonna make some cope and stick doors today. I'm thinking we'll make about 12 doors, and we're just gonna pick 4 different height ranges so that we can see those differences at the cross-cutting operation. All right, so let's start out. Let's grab some, this one I think we're gonna make some cherry doors. How's that sound? Let's make this 22 and a half. Let's add those 3 doors to the list. And if we open up the details, right, down below we can see that we're building that bill of materials dynamically, right, so that every time I order an assembly, all of its components follow along with it and are created on the fly, right? Okay, so let's this here. All right, so at this point we've got 12 different doors, we've got 4 different heights, right? And I could have changed any of these attributes that are user definable, right? But for today's demonstration, the biggest concern is getting our fixed randoms, right? All right, let's save this order and say that's everything for the customer today. So this is gonna be NG728. So I'm gonna come down here and find my cart slot document so I can see that everything has been ordered. Right, so I would print this document. It identifies my cart, right? I can scan the barcode so that cadet can track the product through my manufacturing process, and we see that every component has a specific slot in a specific cart. Okay, let's go run some product. right, so now we're at the Ripsaw at the infeed system here, and we're just gonna come into the Ripsaw software and we're gonna grab the Mill Vision tab. Right, we're gonna do a refresh here, so we should see we've selected our cherry species for doors, and I've got fixed width at 2 3/4, and I've got a random width stave range of 1.5 to 4 inches. Right, I'm gonna tell it to import all of this data. And the magic just happened right in front of your eyes. You may not have seen it, but the Ripsaw has forwarded all of the components for the cross-cutting saw, so the Dimpter knows exactly what to cross-cut for what we're ripping right now. Okay? Let's rip some stuff. Adam, you want to help me out? All right, this is Adam, and he's going to help me with the Ripsaw here today.
Boards, we're going to optimize them. It's going to go to the moving blade ripsaw, and so the moving blade ripsaw does two things here. It determines the proper optimization for the board. The second most important thing is, as each ordered item comes to completion, it's going to stop making that thing. One of the big values of the rip cut line is we only make what's ordered. Yield, not making things you don't want, should be a big part of that calculation. So now the board is coming to the ripsaw. Hit this reset, it's going to send over to the lateral chamber. All we're doing is we're transporting the boards over to our operator who's marking out what the cabinet is and what's not a cabinet. Goes up that incline station over that fence. It's got a pinch wheel. We have the width measuring on the front of the Dimpter. Parts are eligible for that specific board. It's getting chopped, identified with the inkjet printer, and now cart slotted per that at the end. And so what the inkjet's doing is telling me the cart identity and the bin. Every cart has an identity on it, so immediately upon cutting, we know exactly where to put it, organized to the assembly. So the 12 doors that we ordered are now ready to be run. So even I know where to put this. Growing. So you can see the size prioritizing the fixed width. But as you start introducing the wider parts, you're going to start getting the random. So we're going to accumulate the randoms by height to try to get the top accumulation of panel fittings that we can then cover and drain of our panels to work. We offer additional stations for layup and integration into a router. Once we glue up those panels, we can put a barcode on, take it to a CNC router to the outside door profile and the outside. All right. So how we look? All right.
Yeah. All right. So right now we've got our fixed width coming off, right, and everything is slotted to that specific part, and that specific slot ID that we pointed out earlier on the documentation, right? And what we've done here to make it simple for the operators is that rails and stiles get kicked to this kicker here, whereas my random width staves are going to be over here. So I can see these are assigned a panel and a slot, so that these can go off to Glua while these components go to get other secondary machining.
identified here in the cut list. So when you import it to Ripsaw, it took this into account and calculated this entire screen of all the parts that we want to make. So you can see all the parts back there. So you can see everything, all the fixed widths are done, all the plow and rail are done. Right. And so once you want to start a new job in the import over here, it's going to overwrite what's here, and it just begins anew. Okay? Oh yeah, fine. Good. All right. So that said, this is our rip cut line. So he's just finishing over here, right? And so if you look at the cart, we ordered 12 doors, I think, again. Right, and so
12 doors again.
So we should have 48 pieces, style rail and 24 bins, and so I think that's it.
All right, Daniel. Just in case, because there was a little bit of noise, especially over here when Nathan was trying to talk to us in the park. Explain a little bit more again what we just saw.
Okay, so effectively, we took an order for 12 doors. That could have been 120 doors. That could have been 5 doors, right? Depending on your volume, right, will determine the level of automation, whether incorporate how much material handling, or if it's just a chop saw and a rip saw, or at what point you need an optimizer to complement the whole thing. Because we want to justify once you get to the volume, we can pay for it. Right, but what we want to do is we want to build a integration. So you might start with the dempster, then add a rip saw, then add the material handling between the two. Right. So effectively,
so it's scalable.
Well, yeah, and this is good for furniture, right? If you think about like furniture components, most woodworking components are either random glued up panel or fixed width. Fixed width components, right? So we just did doors here as an example, because it's got a 50-50 split between fixed width and random. Right. And then you think about furniture, it has about the same proportionality. Right. In a rip first line, if you think about it, right, how it compares to traditional woodworking, where I'm ripping dimensions and I don't know how much I've ripped, so I typically over-rip, and I rip for yield, not cost. Right, by ordering 12 doors, this is a fairly short run, right, and having the rip saw stop as soon as I'm finished, right? Okay, I don't pay for things I didn't need.
Right. Good point.
Right, and that should be your yield yield calculation should be cost, not fiber.
Nice. Yeah.
Right, but by using the moving blade rip saw, we're getting fiber yield because we're maximizing the yield of every board with the potential of the order. But then we never make a strip we don't need. Right, and so that's how you should factor. That's how we want to pay for our equipment.
Very good.
And then increasing the speed.
Very good.
And then you have all the organization. So now you're also on the chop style. We're not cutting a pile of dimensions, having to figure it out. It's organized to the assembly.
You put a part in a slot. It tells you what slot to put it in.
Yep.
You needed 12 doors. There's going to be 24 parts. There's 24 slots there. If you have more than that, you've made too many parts.
Now, if you want to mold, right, we can flex the line so that we can put a printer behind the rip saw to identify the molding and the order, so we can pull the fixed widths off. So the rip saw will only forward the randoms out here. We'll cut the center panels. Nice. We'll pull those fixed widths off, create collections of moldings that we run through the molder, then onto a push feed chop saw. Depending on how you want to do it, we can rip cut, we can rip mold cut, and rip mold stave cut. A complete flex line. Right, so depending on what you want to do and what your volumes are, we'll determine how we want to roadmap that to a successful plan to implement so you guys can keep that manufacturing here in the USA.
Very good, very good.
Yep.
Thank you so much. Anything else?
No, good.
Did I get it all?
Yeah.
Daniel and Nathan, we thank you for this. Jonathan and Adam, appreciate you guys stepping in and helping us run this. For the whole team at MHD to put this together, it was a big deal. We hope that you guys have learned something. We hope that you're seeing what you can do, how automation can start. When we think of automation, a lot of times in the solid wood industry, we immediately think that you have to spend $5 million to do this. This is a good way to step into it. It can become scalable. You can grow as your demand grows. All right, so we're going to wrap this up. Again, thank you for all of this. But one thing on the schedule, there's one more demo that we're going to do for you guys in just a few minutes, and it's not on the schedule. So please stay tuned. We'll go and we'll be unveiling something else that's a little special for you. So With that, we're done with this one.
Thanks
Thank you
for your
very
time.
much. Have a good
Thank you.
afternoon. Well, all right, very good.
You think everybody enjoyed Michael?
They're behind the camera. Nobody saw him. I just got to thank the talent. All right, let's see how we get over here.
No one's sweating.